Welcome to my channel. Today our learning objective is prove and apply the trigonometric identities. This is chapter number 6, trigonometry and bearings, and we are doing exercise 6.4. Now first we will prove the trigonometric identities. There are three types of trigonometric identities. First we will prove the reciprocal identities. These three are called the reciprocal identities. Cosecant theta is equals to 1 over sine theta, secant theta is equals to 1 over cos theta, and cot theta is equals to 1 over tan theta. Before proving their trigonometric identities, these reciprocal identities, we will see the definition. What is the trigonometric ratio? The trigonometric ratio is the ratio between the two sides of a right angle triangle. Is called trigonometric ratios. There are 6 possible trigonometric ratios. So here is a triangle. These are the 3 sides of the triangle. The side which is the largest side is called hypotenuse. The side which is in the vertical direction is known as perpendicular, and the side which is in the horizontal direction is known as the base of the triangle. So now this is the right angle triangle, the perpendicular, hypotenuse and the base. Here the angle C is the right angle and angle A is one of the acute angles. There are 2 acute angles in the triangle, the angle A and the angle B. So in a standard form, the right angle and the acute angle theta was on the base of the triangle, and the side in front of the acute angle is known as perpendicular, and the side in front of the right angle of the triangle is known as the hypotenuse. Here it is a 90 degree, it is the largest angle of the triangle, so side in front of it is hypotenuse, which is the largest side of the triangle. So how the 6 trigonometric ratios are possible here? As we already know that sine theta, in our previous video I have told you about the 6 trigonometric ratios in exercise 6.3. So you can watch that video for full understanding of this. So sine theta is equals to perpendicular divided by hypotenuse. So sine theta is equals to A divided by C, and the cosecant theta is equals to hypotenuse divided by perpendicular. So it will equal to C divided by A. From the definition of the trigonometric ratio, we know that sine theta is equals to A by C, and by that definition we also know that cosecant theta is equals to C by A. So let's prove the first reciprocal identity. Now take the sine theta is equals to A by C. Take the reciprocal of the sine theta is equals to A by C. Now 1 over sine theta, and this is C by A. If we take the reciprocal of this ratio, we will get 1 over sine theta, which is equals to C by A. And we also know the C by A, the hypotenuse divided by perpendicular, is equals to cosecant theta. Now putting the value of C by A here, so 1 over sine theta should be equals to cosecant theta. Similarly, you can prove the other 2 reciprocal identities. We will start from the cos of theta and then write the ratio of secant theta. Then take the reciprocal of cos theta and put the value of secant theta. Similarly, start with the tan theta, take the reciprocal of tan theta and put the value of cot theta. So you can prove all the 3 trigonometric identities. These are called the reciprocal identities. Now let's see the other identities. These are called quotient identities. So these are the 2 identities. The first one is tan theta is equal to sine theta over cos theta, and second one is cot theta is equals to cos theta divided by sine theta. Before starting the proof of the first identity, the tan theta is equals to sine theta, you will construct a triangle like this. The triangle ABC, in which angle C is equals to 90 degree, angle A is angle theta, and the hypotenuse is equals to C, the perpendicular is equals to A, and the base is equals to B. This is the construction of a right angle triangle, and you will write all these construction here, which I told you in words. Here by definition means the definition of trigonometric ratios. By definition we know that what we know that sine theta is equals to A divided by C, perpendicular divided by hypotenuse. So A divided by C. And we also know that by definition that cos theta is equals to base divided by C, which is hypotenuse. And we also know that tan theta is equals to perpendicular divided by base. These are the three trigonometric ratios that we know by definition. And now as we know that tan theta is equals to A divided by B. Now dividing the numerator and denominator with the C. So I am dividing the numerator with the C and I am dividing the denominator with the C. So as you can see that A divided by C and B divided by C. So A divided by C is equals to sine theta and B divided by C is equals to cos theta. So hence the trigonometric ratio tan theta is equals to sine theta over cos theta. So similarly you can prove the next identity. How? As you know that by definition you will write that by definition the cot theta is equals to B divided by A. Now divide the numerator and denominator with C, B divided by C and A divided by C. So B divided by C is equals to cos theta and A divided by C is equals to sine theta. So hence the second trigonometric identity is proved here. Now there is a third type of identities. These are called the Pythagorean identities because they are similar to the Pythagoras theorem and we need the Pythagoras theorem to prove these things. So these are known as Pythagorean identities. So to prove these identities you need to construct a right angle triangle before starting that proof. First you need to construct the triangle as I shown you here, the angle C, A and B, side ABC. Write all the description of this picture. We have to use Pythagoras theorem to prove these identities. As we know that the square of the hypotenuse, which is C here, and equals to the square of the perpendicular, which is A, plus the square of the base, which is the B value here. Now C square is equals to A square plus B square. As we know that these trigonometric ratios are the sine theta is equals to A divided by C. We know that the cos theta is equals to B divided by C. To convert this vector into A divided by C and to convert this B into C, we have to divide the complete equation on the C. So dividing this equation both the side with C square. So here C square cancels C square, it is equals to 1, and here A divided by C into whole square. Similarly B divided by C into whole square. Now A divided by C, by definition we know that A divided by C is equals to sine of theta plus B divided by C by definition is equals to cos of theta. And now we will get the proof sine square theta plus cos square theta is equals to 1. For example, if we want to prove the cosecant square theta minus cot square theta, what should we have to do? As you know that cosecant is the inverse of sine theta. So sine is equals to perpendicular divided by hypotenuse. So it means C divided by A, the hypotenuse divided by perpendicular, is equals to cosecant theta. Similarly, the cot theta is opposite to the reciprocal of the tan theta, which is equals to perpendicular divided by base. So if we divide base with perpendicular, we will get cot theta. Now use the Pythagoras theorem. You know that c square is equals to a square plus b square. Hypotenuse square is equals to perpendicular square plus is equal to base square. So to make the things c by a and b by a, you have to divide this equation with a. This is the hint, c by a and b by a. You have to divide this equation with a square value. So c square divided by a square is equals to a square divided by a square and b square divided by a square. So here a square is cancelled here. So c divided by a whole square plus 1 and b divided by a whole square. Now as we know, c by a by definition is equals to cosecant, because square, so cosecant square theta is equals to 1 plus cot square theta. Now rearranging this equation, cosecant square theta minus cot square theta is equals to 1. So the first identity and the third identity is proved here. The second identity is very easy. You can solve it as I solve these two identities. You can solve it yourself. Now we'll start question number 1, part number 1. 1 minus sine square theta into secant square theta should be equals to 1. Now left hand side of this identity is equals to 1 minus sine square theta into secant square theta. So as we know that sine square theta plus cos square theta, a Pythagorean identity, is equals to 1. And from this identity we know that cos square theta is equals to 1 minus, if we take sine square theta to the other side of the equation, is equals to 1 minus sine square theta. So 1 minus sine square theta is equals to cos square theta. So now we will put the value of 1 minus sine square theta here, which is equals to cos square theta. We also know with the help of reciprocal identities that secant theta is equals to 1 over cos theta. So now putting the value of secant theta here, 1 over cos, because it is square, so it is cos square theta. Now cos square theta cancel with the cos square theta, and our left hand side is equals to 1, and our right hand side is also equals to 1. So left hand side is equals to the right hand side. Hence our trigonometric identity in the part number 1 is proved here. In the same way, we will solve the second trigonometric identities. So this is 1 minus sine theta divided by 1 plus sine theta, and it should be equals to secant theta minus tan theta whole square. So now we know that 1 minus sine theta and 1 plus sine theta. Now take the left hand side of this trigonometric identity, which is equals to 1 minus sine of theta divided by 1 plus sine of theta. As we are fully aware that sine square theta plus cos square theta is equals to 1, and we also know that the cos square theta is equals to 1 minus sine square theta. To convert this value into secant and tan, you need 1 over cos square theta and sine square theta over cos square theta. So it is a hint that secant theta is telling you that it is equals to 1 over cos theta, and similarly tan theta is giving you an information, the sine theta divided by cos theta. So here in the denominator we need cos theta to solve this side and convert it into the right hand side. So we get our objective. We have to convert this thing into cos theta. To convert 1 plus sine theta into cos theta, we need to convert 1 plus sine theta into 1 minus sine square theta. How we can do that? As you know, in the algebra, you know that if there is a plus b, you can multiply a plus b with a minus b, and you will get a square minus the b square. So now we will multiply the denominator with 1 minus sine of theta, because we want 1 square minus sine square theta, and we want to convert the denominator into cos theta. So now we are successful here, and because it is mathematics, so in math you can divide with the value, then you have to multiply with the same value to an expression. So we have to multiply with 1 minus sine theta and divide with 1 minus sine theta. And now what we will get? We will get 1 minus sine theta, 1 minus sine theta, the whole square of 1 minus sine theta as a whole square. And in the denominator we get 1 square minus sine square theta. So 1 minus sine square theta. So 1 minus sine square theta is equals to cos square theta. So we will put the value of cos square theta here, and above there is sine theta 1 minus sine theta whole square, because the numerator and denominator both are the square value, so we can write both of these values in a single square value. So 1 minus sine theta divided by cos theta as a whole square. And now because the denominator is single value, so we can shift it below. So as the denominator, we can split the denominator under the 1 and the sine theta as 1 divided by cos theta minus sine theta divided by cos theta as a whole square. And now you can easily see 1 over cos theta is equal to secant theta, and sine theta over cos theta is equals to tan theta, and the whole thing is under the square. So in that way the left hand side is equal to the right hand side. So the second trigonometric identity is proved here. Now here is the third trigonometric identity. 1 minus cos of theta over 1 plus cos of theta in the under root sine is equals to sine theta over 1 plus cos theta. Left hand side is equals to under root of 1 minus cos theta and 1 plus cos theta. Okay, to prove the right hand side, as you see, there is no sign of under root. So first we have to eliminate the sign of under root. The easiest way to get rid of under root sign is that if there is an under root sign and below there is a value, a variable with a squared value, then under root will cancel itself. So here the expression is not the square. So somehow try to convert this expression into a squared expression. The first objective, convert this value into a square value. This is your first objective. The second objective is that you need to retain the denominator. The 1 plus cos theta is equal with here 1 plus cos theta. So don't change 1 plus cos theta. Do not destroy your denominator. Keep your denominator as a 1 plus cos theta here. So to fulfill this objective, if I don't want to change the value of cos theta and I want to convert 1 minus cos theta into sine theta, so what will I do? Let's see. 1 minus cos theta and 1 plus cos theta. Now multiply and divide this expression with 1 plus cos theta. Why 1 plus cos theta? Because 1 plus cos theta into 1 plus cos theta will give you a complete square of 1 plus cos theta. This will convert into 1 minus cos square theta and 1 plus cos theta as a whole square. Now 1 minus cos square theta, we know that sine square theta cos square theta is equals to 1, and 1 minus cos square theta is equal to sine square theta. So now we will put the value of 1 minus cos square theta here, which is equals to sine square theta divided by 1 plus cos theta whole square under root. Now both value are the square value, so we can write them under the single square. So sine theta divided by 1 plus cos theta into the single square value. And now we will get rid of our square root here. The square root will cancel the square and we will get the same value which is on the right hand side of this trigonometric identity. In this way you can prove the third identity. The remaining trigonometric identities will be solved in my next upcoming video. Because the video length is too much, so to keep the length of the video in the limited minutes, I will have to decide I will make the 2 video of this exercise. So in the next video you will see the part number 4 of this exercise. If you understand this video, share it with your friends. If you want some improvement in it, comment on the YouTube. So I will make the improvement in the next upcoming videos. Thank you very much.